If you're into data science, compulsorily you need to know the NumPy library, which stands for numerical Python. NumPy library is to manipulate arrays. They can be one-dimensional, two-dimensional, or any dimension, but they're just arrays. And every element in the array must be of the same type. That is, they must be homogeneous in nature. The reason we would prefer NumPy over a list to manipulate arrays is the mathematical operations that are allowed on the arrays and matrices are huge, and it is faster. And they're also extensively used in Panda, SciPy, Matplotlib, and Scikit libraries. First, let's install NumPy with pip install NumPy. And we can import NumPy as NP, and NP is a universally accepted word. NumPy can work on one-dimensional arrays, which are called as vectors. And if you want to initialize a NumPy array with one-dimensional values, we write np.array, and we have to give a list inside. And remember, all of them have to be of the same data type. The object that is created is an ND array, and the data type of each element is a float. I have created a single dimension. Now let's see how to print all this. We can get the data type of the object using type of X. We can find the data type of every element using dtype. So we use x.dtype. I can find the shape of my NumPy array using x.shape. I can find the number of elements in ND array using size, and the number of axes is given by x.endtime. So the values are these three. It is of type ND array. Every single element is a full float 64, but I want you to concentrate here. You might have looked at it as an array of single row with 3 elements. But if you want to use a NumPy array, this is how we will view it. That is, there are 3 rows and a single column. Basically, these are column matrices. These are not row matrices like the ones that we are used to. So now the number of axes is, so when we create a 2-dimensional array, we have to use np.array, and we need to use a list of lists. So in the list, there are 2 lists internally, or there are 2 sublists. This shows that there are 2 rows. Each row has 3 columns. When we print the various attributes, we see that this is the value. It's an ND array. Every element is of type int64. The shape is that it has 2 rows and 3 columns. There are totally 6 elements, and there are 2 axes. It is possible that we want to create a range of numbers, in which case we use arange, and we specify the total number of numbers. That is, if I specify 10, it starts from 0 to n-1, which is 9 elements. If I want all zeros and all the elements are of type float 64 by default, I use np.zeros. If I want all ones, I have np.ones. And if I want to create an initially empty ND array, I use np.empty with 4 elements. But remember, the values that can be in this empty array is random, and it depends upon the state of the memory. The output of the following would be as follows. This is the output of a range of 10. This is zeros of 4. This is ones of 4. And this is empty of 4. Please note that this value is extremely subjective. In all of the above, I can also specify the data type that I want using the second parameter, which is dtype. And here I say that it has to be an int64. That is, I mention it as np.int64. If you look at the output, I have an empty array with 4 random values. What if I want a range of values, but I want to specify the starting and the ending values? I can specify the starting value as 1. I can specify the ending value as 10. And I can also say the spacing between the elements. Like, for example, I start at 1. 1 plus 3 is 4, and 4 plus 3 is 7. 7 plus 3 is 11. And since it falls outside the range, we have only these 3 elements. So now this is a column vector of size 3. The next one is linspace. In linspace, we can create a uniform linear spacing of elements. A linspace is very useful to create a range of numbers in which there is a equal spacing between the elements. So for now, I have said that I want the numbers between 1 and 10, 10 inclusive. And if I say num is 5, I want 1 to 10 range to be split into 5 equal intervals. So here I have it as 1, 3.25, 5.5, 7.75, and 10. Thank you.